Okay, so thank you for joining me in this session about Camelets and how to use them to connect the world to your event-driven application. So my name is Christoph, and I'm working as a software engineer at Red Hat at the projects Apache Camel, Camel K, and Camelets, which is our topic today. So before we start to learn about Camelets, we need to explore a bit where this is actually coming from. So Camelets are a part of the Apache Camel software project. And this is an open source project and widely known as the Swiss knife of integration. And it provides a lot of components for you to actually deal with different data formats, and Camel implements the enterprise integration patterns. So every time your application connects to a third-party library and has to do some messaging transformation from one data format into another, or has to do content-based routing and all this stuff, Apache Camel is there to support you with components and language features. So it's a very mature project, 16 plus years of development, and still one of the most active Apache projects. And currently it's available in the version 4.0.1, which aligns with the major versions out there of Quarkus and Spring and so on, also doing the migration from JavaX to Jakarta and so on. So why is Apache Camel still active and still so well known? Of course, the community, which is great around Apache Camel itself. But the project itself has also grown an impressive list of sub-projects. So the integration with Quarkus and Spring and Kafka. And one of these sub-projects is also Camel K, which focuses on running Camel workload on Kubernetes or Knative. And Camelets were born in Camel K. So initially this was introduced as a concept in Camel K. But nowadays you can use Camelets everywhere. So it doesn't matter if you write your Camel application on top of Quarkus or Spring Boot, or if you run this on Kubernetes, or if you don't run this in Kubernetes. So everywhere you have the Apache Camel, you can use Camelets. And Camelets mean route snippets, so they leverage the concept of route templates in Apache Camel. And the idea is to actually use a route, which is a Camel logic, and make it reusable across multiple projects, across multiple scenarios, and make it usable for many, many users. And a Camelet tries to reduce the complexity of an integration problem, meaning if you need to connect to the outside world, if you need to connect to a messaging platform, or if you need to do some specific things in message transformation and so on, a Camelet will try to make it easy to use such kind of functionality, and this is reached with a kind of opinionated process. So a Camelet will always shrink down a bit the functionality of a Camel component. So a Camel component may have a huge list of properties and a huge list of features that are supported, and the Camelet tries to shrink this down a bit to gain ease of use and to reduce complexity and to hide complexity. So why are we doing this? Event-driven is a widely used thing today. So many projects and many technologies out there make use of event-driven. And not all Java developers may be experts in Apache Camel, although Camel itself is not very hard to learn. So if you're a Java developer and have a look at Apache Camel, the getting started is quite simple. So as Apache Camel tries to already reduce the amount of knowledge that you need to connect to a third-party service, to AWS or to Google Cloud or whatever. But still, there are some integration challenges that need kind of expert level, and not everybody has this. So a Camelet tries to get on top of this and be an additional abstraction layer that reduces the complexity for you, so that you can just use the Camelet and the power of Apache Camel behind it without being a Camel chef yourself. So the development process could look like this. A Camel developer that is knows Camel writes a Camelet and pushes this into a so-called catalog. So the catalog could be the open source catalog, which is available in the Apache Software Foundation. It could also be a private one for your company. And once the Camelet is listed in this catalog, the idea is that every app developer can make use of it. And the app developer does not necessarily need to know Apache Camel. So all the complexity that may be linked to the integration problem that you want to solve might be hidden, and you just use the Camelet and put it into your environment, whatever you are writing. You could be writing an event-driven application. You could also use this in an arbitrary server-side application with a REST endpoint or something like that. So the Camelet catalog, as I said, is a list of Camelets. The open source catalog in the Apache Software Foundation is already a huge list of ready-to-use Camelets. And each Camelet stands for connecting to third-party services like AWS or Google Cloud or Azure or whatnot. And the idea is that you can go there, pick one of these Camelets, put it in your, or reference it in your code, and then you just need to give some kind of input properties and can use them. We know 3 types of Camelets. So there are sources, sinks, and actions. And the source will connect to an outside service like AWS, grab some data, and put it in the platform that we are using right now. The sink is the other way around. So we take some data from our platform and push it to the outside world. In this example, obviously saving a file to Dropbox. And the action can be as a step in between. So you link a source with a sink, and in between you can have some steps, and you can reference Camelets of type action. In this example, the PDF action will obviously create a PDF out of the content, and then the PDF file is pushed to Dropbox. In general, Camelets are platform agnostic. This means they are not bound to the underlying messaging platform. So if you are writing your application on top of Knative, you can bind the very same Camelet, here the Telegram source, to a Knative broker. If you write it on top of Kafka, for instance, you can bind the same Camelet to a Kafka topic. Or you can also bind it to your service with HTTP. So this is very important, because then the Camelet really gains reusability across various scenarios and is generally not bound to the underlying messaging platform. I don't want to go into much detail about writing a new Camelet. This is quite easy because it's only a single file. But in this session, I want to focus on using existing Camelets from the catalog that we have seen. But just for you to know, if you write a new Camelet, you need to give a configuration schema. This lists the properties that a user needs to provide in order to use the Camelet. Can be required or optional properties. And on top of that, you can define data types, like if your Camelet requires a specific JSON input structure, then you can declare this. Or if your Camelet produces an output in a certain JSON structure, then you can also provide this in a data type. And all this information is there to give tooling and UIs the opportunity to actually leverage this information and to have a human-readable output where users can go there and just see, I want to use this Camelet, what do I need to provide? This and that authentication token or this authorization and so on. And secondly, there's the route template. This is the actual Camel logic that is put into the Camelet, and this is a normal route in Camel where you can use all the power that Camel uses, like doing the message transformation or content-based routing, filtering, and whatnot. And this is then what actually is called when the Camelet is referenced and is run. Again, I don't want to go into much detail about writing a Camelet. This is an example so that you have seen an example. It's a single file, usually a YAML file, because it's also used as a custom resource later. So the thing for you to know is, again, this configuration part where you define the properties, like here the access token and the client identifier. And on the right-hand side, you have this Camel route template which when you're familiar with Camel, you have this from, then you have some steps in between, like a choice or a filter, and then at the end you have the to, and right here we are using the Dropbox component. This is one of the 300 components that I've mentioned earlier that is provided by Camel to actually put the file to Dropbox. So if you want to use Camlet, how can you do that? If you are familiar with Apache Camel and use the normal domain-specific language with the from and the to, you can just use the Camlet as a normal component. So one of these 300 components is also the Camlet component, so that you can just say from Camelet, say the name of the Camlet. Here it is the foo source, and you give some input properties. These are the properties declared as required. And then you are happy, and then you can use the underlying route template that is boxed into the Camlet. And also in the to section where you have the Camlet barsync, this time we want to send out some data, and then you just reference the Camlet. For running this on your local host, I recommend using JBang because it's the easiest way to get started. There's a Camel JBang integration where you just say camel run, and then you can run your integration, and you have this on your local host. Same thing when you want to run this on Kubernetes. As I said, Camlet is a custom resource, and you just say camel run now with the normal K, and then you use camel K as a runtime on Kubernetes or OpenShift, and this will take your Camlet and just run this on Kubernetes. And last not least, there's the pipe, which gets you a source in the sink, and in between you can have some steps. And this is the most declarative way of using Camlets. So you can just use control apply -f and use this as a custom resource to also run this on your Kubernetes cluster. So speaking of pipes, as I said, if you are a non-Camel user and you don't have Camel in your portfolio at all, you should just be able to also use these Camelets with the pipe that just links a source with a sink. So again, this is the most declarative way of using a Camlet. So you say, I have a source of type Camlet, or it could be a Kafka topic or a Knative resource, and I want to link this with a sink using also some of these resources like a Camlet, a Knative resource, and the Kafka topic, and I can also bind this to an HTTP URI. And this is, as again, the most declarative way of using the Camlets when you are a non-Camel user. And it's a YAML file again, because it's also used as a custom resource. And I would not go into much detail, because this, we will see this in the demo later on. And looking into your faces, I can maybe see something happening in your brain right now. Throwing too much YAML exception, because not everybody likes YAML for good reasons. But again, you are not bound to using this in this declarative way in the pipe. You can also write your normal Camel code as a Java developer using this route builder, and use the domain-specific language like the the from and the to, and can reference the Camelet. So it's up to you. Whatever language you prefer, you could do this in Kotlin or Groovy. It's always the same. So right now we have hopefully learned a bit about Camlets, and let's have a look into how this looks in action. So I have prepared a little demo application. This is a Quarkus application, and it runs on top of a database, or runs on a database, and it listens for incoming events on a Kafka topic, and these events will be of type booking. So it's very simple. You have a product, you have an amount and a price, and the application will also listen for supplies, so that when a user puts in a booking and a supplier puts in a supply, and these two actually match, then the application will complete the booking and send out a completed event, a booking completed event, and it will send out a shipping event. So in this demo, we want to have Camelets acting as event sources, creating these booking and supply events, and we want to have Camelets as sinks, consuming the booking completed events and the shipping events, and to push them into the outside world. And we want to have some different event types. So in this demo, we will use Google Sheets and Slack integration, Webhook integration, and whatnot, to have different types of incoming and outgoing sources and sinks. Yeah, this is the demo is also provided in GitHub, so you can go there and actually have a look, and maybe run this also on your local host. So let's just jump into the demo. So I'm starting this Quarkus application. Can we see this? Yeah. I'm starting this as in dev mode on my local host, and this will run not only the Quarkus application, but also will create the Kafka broker and the Postgres database in test containers for me. So this is the Quarkus dev mode that everything runs on my local machine. And now this should be listening for incoming booking and supply events. So let's create some. And again, I will show you the pipes, because it's the most non-camel user-friendly one. But again, you can also use this in your Java or Groovy, Kotlin, whatever you like. So the pipe in here, it starts with a very simple timer source, which will periodically generate these booking events. It's a very simple JSON, gives it a product. Everything is static, so very simple, just to show you. And every 5 seconds, this should then fire this event. And in the steps section, I'm logging, because we want to see something happening. And in the sync section, we can directly bind this to a Kafka topic, which is a Strimzy custom resource. And this will then connect the timer source with the Kafka topic of type bookings. So let's start this. Can you see that? I'm using a Camel run here, which obviously uses the JBang application. And JBang is really, really great to get you started on your local machine, just trying things out and having it run. You now see that we generate every 5 seconds this booking event, and this should send this to the Kafka topic. I'm also using the dev mode in Camel JBang, which gives me the hot reload. And if I go to the Quarkus application, then we should see that this is already processing the incoming booking events. So what's missing now is also generating the supply events, so that booking and supplies do match. So for the supply pipe, I'm starting with a webhook source. This is a Camlet that creates an HTTP endpoint. so that users can go there and have a GET request on this endpoint and give some HTTP GET query parameters like the client, the product, and so on. And in this set body action, I try to set the read the information from the header, because the webhook source Kamelet will automatically translate the HTTP GET query parameters into headers. So I can access this with a simple language expression. This is some Camel specific here, but quite simple. I extract the header information to actually put this in a valid JSON representing a proper supply. And I'm logging things, and then I'm binding this to the supplies Kafka topic. So let me just say camel run. So now I should be able to go to localhost and just fire this event. And in the bottom, if I repeat this request, you will see that the webhook then creates this supply event. And if I'm going back to the Quarkus application, now that booking and supply events match, we will also close bookings and generate these shipping events. And the next step would be to also receive this on the sync side. So let me go and show you the simple log sync. Again, we're using the pipe here, and now in the source, we're using the Kafka topic because we want to read events from the Kafka topic. This is the completed booking events topic, and we bind this just to the log sync, just giving this to the output. And same for the shipping events. It's exactly the same. So when I start this with camel run, I should be provided with booking completed events, because the timer periodically sends in booking and we have some supplies in the system. And then the booking events should also be received here with the status completed. And on the shipping side, we also receive these shipping events. You can see this because here we have an address field, and this is generated by the Quarkus application. So now on both sides of the application, we create some events and we receive some events on sources and sync side. So let's have some more fun with Google Sheets. So in this pipe in here, again, I'm listening on the shipping events Kafka topic, and then I'm doing some logs. And as a sync, this time I'm using the Google Sheets sync Camlet, which is also ready to be used in the catalog. And this time I need to provide some more information, like the OAuth authentication, like access tokens and client secrets and so on. By the way, these properties are resolved with the application properties file that are automatically run with Camel JBang. When we push this later to Kubernetes, we are using a secret that resolves the properties that we have in here. So let me start this one. Maybe also start a timer for the supplies so that we don't run out of supplies. So this is the Google Sheets sync. And now I should be able to actually start seeing some data, because the sync will write the data into the sheet. And I have prepared a little graph in here that just shows the amount of sources. And I almost forgot, because I was starting this in the dev mode. So if we can change this. And also for the supplies, because we need it of the banana of the same product. And if I go back to Google Sheets, this now will restart because I have it in dev mode locally. So it takes a while, and hopefully I can receive some. Here we go. now we receive these different booking and supply product. So let's move on and have some more fun with Slack. So in this pipe, I'm using the Slack source to connect to a Slack channel, and when a user goes in there and types in some specific text, I'm jumping a little bit because I'm running out of time. I have this text here, hey bot, create new booking, and when a user types this into the channel, then I want to create also a new booking event. So I'm doing some steps to actually convert the plain text into a proper JSON, and I'm binding this to the bookings. And on the other hand, I want to receive completed booking events also in the Slack channel. So this time I'm also connecting to the Kafka topic and extracting some fields from the JSON and setting here a plain text body with, hey, client, your booking of type product and so on has been completed. And with the Slack sync Camelet, I'm able to write this into the Slack channel. So let me just start these two. Again, this uses then some bot token and some Slack application tokens. And now if I go to the Slack channel, I should be receiving from the timer, which is using the banana. I should receive now these events for time booking completed. And if I just say I want to have pineapple, then I need, let me just fire 2. I need to go to the webhook and create some supply for pineapple. And hopefully, yeah, here we have this pineapple completed. So at one point, you are happy with developing everything locally. And I have started some Camel JBang integrations, some pipes in here. And at one time, you may be happy with your local development, so you can just stop everything. And the next step would be to push this then into the cloud. So I can show you here, I have a OpenShift cluster prepared. Maybe let's make it a bit bigger. And for pushing this, or just for explanation here, I have this food market application. This is the Quarkus application already deployed, and it's connected to a database. And this is the Kafka Streamzy cluster already running. So what is missing is the Camelets. So to push these into the cloud, I can say OC apply -f. As it's a custom resource, I can say here, Kubernetes cluster, this is my custom resource of type timer source booking. And here we see this already pops up because this is then running in Kubernetes, and also every 5 seconds it fires this booking events connecting to the Kafka cluster. Let me just also start the supply. Where is it? Supply. So how is it working? In my Kafka, or in my OpenShift cluster, I have some operators installed. This is the CamelK operator, and what Camel JBang is doing locally, CamelK operator is doing on Kubernetes. Taking a custom resource, taking this pipe, creating the proper runtime, and just run this on the cluster. And last not least, then I'm also running out of time. I will start the Slack source integration. This is the Slack sync, and I'm starting the webhook. And what CamelK operator is also doing for an HTTP-based source, it creates a proper service and a proper route so that the actual webhook is accessible from the outside world. This is the GET request, and I'm firing this for bookings and supply. And I'm using Strawberry in here. So I should receive here the booking completed event for strawberries now in my Slack. So this is now running on Kubernetes, and my time's already up. I'm also finished. Let me go back and just show you the last slide one more. And yeah, if you have questions as we are running out of time, please come to the desk and I will be happy to answer your questions. Thanks.